Okay, ladies and gentlemen, this video is on introducing completing the square concept. Completing the square. So first of all, let's do a little research or observation here. Notice right here I have a perfect square, right? I have a binomial squared. So let's just go ahead and expand and use distributive property. Does everybody agree that this is the same thing as x plus 3 times x plus 3? In other words, that's what that squared power means, right? I have two x plus 3's and I'm going to multiply them together. Well, when we do x times x, that of course is x squared. And when we do x times 3, of course that's 3x. And then we're going to go ahead and do another 3x, right? Let me clean that up a little bit here. So then we're going to do 3 times x and get another plus 3x. And then finally 3 times 3 is 9. And of course we could put these like terms together. So our end result is, so combining those like terms, we end up with x squared plus 6x plus 9. Okay? Now the pattern I want you to notice already is, see how the 3x's will double up when we square the same number 3, right? And of course, we also notice we get a 9 because 3 squared is 9. And this is a pattern, guys, that you need to recognize. So let's try one more. Does everybody agree that we have x minus 7 times x minus 7? And we're again going to do x times x and get x squared. We're going to do x times minus 7 to get minus 7x. We're going to do minus 7 times x minus 7x. And minus 7 times minus 7 is plus 49. And see right there how they double up again. So our end result again is x squared, this time minus 14x plus 49. So again, notice the 7 doubled up, the negative 7 doubled up. That's where this negative 14x came from. And of course, where did the 49 come from? That's right, it came from the 7 being squared. Okay? So this is a pattern that we're going to use to complete the square. So let's put it into action. But now we have to go backwards. For example, take a look at this problem. We have x squared plus 10x plus something, right? And the goal here is, can you find that number that if I put in there and add it, will make a perfect square binomial? So here's the process. We know that the 10x had to come from a 5x plus a 5x, right? So the process is, I basically take 10 divided by 2. I know that's a 5. In other words, I'm going to take 5 and square it. And I know, therefore, that number has to be what? 25. So again, just to make sure, we know, let's see here, what color? I'm going to change colors here. Follow the gold here, guys. Look down here, bottom left corner of the screen. So again, we know hopefully that the 6x came from 3 plus 3. And we know that the 9 came from 3 squared, right? So 6 was 3 plus 3. 9 was 3 squared. Likewise, look at the bottom right here. We know that minus 14x was minus 7x with another minus 7x. And the 49 came from 7 being squared. And that's the completing the square pattern we're using. Okay? So coming back to this one, do you understand why I added 25? Because now, did I not make a perfect square? I made x plus 5 squared, didn't I? This original term becomes x plus 5 squared if and only if I add that 25. Okay? So let's try it one more time. Take a look at this problem right here. Can you figure out what number belongs right in there? Pause the video and see if you can't figure that out. Okay, so hopefully you looked right here at the minus 12x and you said, hey, you know what? Is it minus 12 if I divide by 2 negative 6 with another negative 6? And that's how we end up with negative 12x, right? So what do I put in here? I'm going to take the 6 and I'm going to square it and get 36. So the number I need there is 36, you see, because when all is said and done, I'm going to have x minus 6. Notice minus 6, right? Watch your signs right there. Squared. X minus 6 squared is the same as the original problem as long as I add 36 to it. Okay? So that's the basic idea of completing the square. So until next time, guys, bye.